Okay guys, so today we are going to look after in this video about the one of the most important theory, or we can say that one of the first theory which was launched in order to explain this coordination compounds, and it was being formed by a scientist called as an Alfred Werner, who was also called as the father of the coordination chemistry. So according to him, he has given it the name of the theory as Werner's theory. So now we are going to see that about its one by one postulates. He says that whenever a complex is forming, for example, if I choose a complex of CuNH3 twice SO4. So according to this, he says that whatever the central metal atom is over here, they will be possessing two types of valency. First one is your primary valency, and the second one is called as your secondary valency. So in a complex, the central metal atom or the ion possesses two types of the valency. He also further explains that primary valency is nothing, it is just the oxidation state of your central metal atom, whereas the secondary valency is the coordination number. Further, he mentions that whatever the primary valency is there, it is ionizable, that is, it is changeable, it is not static, it can keep on changing, whereas secondary valency is a fixed one and cannot be changed. So this was the main thing what he chooses whenever about the central metal atom or the ion. Further, he explains that whenever a complex is formed, what happens, the oxidation state, for example in the above example, if you choose CuNH3 twice SO4, so when this complex is forming, the primary valency will be satisfied by the anions which is present in this complex. For example, in the complex we are having Cu plus 2, that is the oxidation state is plus 2. But in the formation of the complexes, this plus 2 will be satisfied by the minus 2 of sulfate. Minus 2 of sulfate. Whereas in the second case, the coordination number, that is, it is having a coordination number of 2. So the coordination number will be satisfied with respect to the two ammonia ligands, which is acting as over here, two ammonia molecules which is acting over as here as a ligands. So during the formation of the complexes, the primary valency will be satisfied by the anions which is present in the complex or in the molecule. Similarly, the secondary valency will be satisfied by with respect to the number of the ligands which is attaching your central metal atom or the ion. Next most important third postulate, what does it says is, these ligands will arrange around your central metal atom or the ion to give you the definite geometry. For example, if I take, so this should be a CuNH3 4, here it was having as 4NH3. So you have 4NH3 ligands. So when you're seeing as geometry, we could just see that it will be this way. NH3, 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 or NH3. And another case also we could just notice that it can also have NH3, 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 or NH3. So basically, by the arrangement of these ammonia molecules around your central metal atom or the ion, it will be giving you the definite geometry. So first and the foremost thing, what does it say? A central metal atom or the ion possesses the two types of a valency, primary valency and a secondary valency. So primary valency is actually the oxidation state, which is an ionizable. Secondary valency is the coordination number, which is fixed. So during the formation of the complexes, the primary valency will be satisfied by the anions which is present in the molecule, whereas the secondary valency will be satisfied by the ligands which is going to bind your central metal atom or the ion. So these ligands will arrange around your central metal atom or the ion to give you the definite geometry. So these are the main postulates what Werner explains during the formation of the complexes. But also they were having certain limitations. You can only observe over them. That is, it was failing to explain that why the complexes are having the magnetic property. That is, certain complexes will be attracted by the magnet, certain complexes will be repelled by the magnet. And also it was failing to explain why certain complexes are colored. For example, copper sulfate is blue in color, potassium dichromate is orange in color. What was the reason behind it? Similarly, it was not able to explain that why these complexes are having the directional properties. You can able to see that I have written over here as an arrow mark. It is indicating from ammonia to copper. It was failing to explain that why it is having such directional properties. So this was the major thing what Werner failed to explain.